Number 22, what we did is, what I did, blurry. What I did is I already entered in that data for us there, so we don't have to, there we go. You don't have to watch me type it in there. So it's all entered here. There's 30 pieces of data there, 30 test scores, so it looks like it's a class. And stat, calculate, one variable edit, and there we go. So let's find the range. The range is given by the max minus the min. So 100 minus 68 is going to be 32. Interquartile range is 92 minus 78 because that's Q3 minus Q1. And whatever that is, 92, that's 2 and 2. So it's going to be 14. Okay, 14. Find the mean of the data. The mean, scrolling up, is 85. So I would probably say this is kind of on the easier side of tests when you've got, but you only got 14 people in the, or 14 data points inside the, or 50% of your data is within that 14 points. And so I would say that this is a little on the easier side of a test, especially when the average is 85. Standard deviation, though, is 8.6. So 8.6. All right, so how many standard deviations away is a score of 71? So now that we have the mean and we have the standard deviation, we can actually find out if someone scored a 71, we're going to subtract the mean. Okay, then we're going to divide by 8.6. So they are negative. This guy is negative 1.6 standard deviations away from the norm. So that's pretty bad, to be almost, negative 1.5 standard deviations away. Now, 85, hopefully you don't have to calculate that because if you know the mean is 85, you know that your z-score is going to be 0, okay? If it's the mean, it is 0. All right. All right, so a set of data with a mean of 48 and a standard deviation of 6.5 is normally distributed. Find each value given its distance from the mean. Okay, well, this is kind of easy. One standard deviation from the mean means that I'd go 48 here and then 6.5 up. Okay, so positive 6.5, so that's going to be 54.5. Okay, two standard deviations from the mean would be, I do not trust myself, 6.5 plus 6.5, so that's 61. Okay, that's two standard deviations. Negative 1 standard deviations from the mean, 48 minus 6.5, that would take us to 41.5. And then 3 standard deviations from the mean would be 48 plus, and then we're going to put in parentheses here, 6.5 times 3. Okay, that would be 97.5. So pretty rare that you're going to get a 97.5, whatever they're measuring here. Okay. All right. Sketch a normal curve for each distribution. Label the x-axis 1, 2, and 3 standard deviations from the mean. Okay, so here we are. Oh my God, that looks beautiful. The mean is 80 and census standard deviation of 12. The first standard deviation is right about there. The second one is usually right about there. And then the third is way up here. Here's the 0. Okay, and then right about there. Okay, so that looks good to me. 12 would be 92, and then it'd be 104, and then over here it would be 116. Over here it'd be 80 minus 12 would take us to 68. Minus 12 would be 56. Okay, and there we go. That's it. That's all that they're asking. So this would look like this if you did mean plus 1 standard deviation. This would be mean plus 2 standard deviations. And this would be mean plus 3 standard deviations. This is the, my bad. That is the mean. This is the mean minus 1 standard deviation. This is the mean minus 2 standard deviations. And the third standard deviation would be right about here. So that would be the mean minus 3 standard deviations. So 56 minus 12 is going to give us 44. Okay? And that's all. That would give you all the points. Same process for this. This guy, let's see if we can draw a nice little curve here. The bottom line actually is not too good. That's going to be 65, and then you're going to go 5.5 this direction, 5.5 again, and then finally again, right about here, here, and here, okay? 5.5 here, 5.5 is this way, okay? All right. Set of data has a normal distribution with a mean of 66.2 and a standard deviation of 1.5. Find the percent of data within each interval. Okay, this is good stuff. This is using from the tables. There's going to be a lot of this on the test. Okay, so let's see if we can use the empirical rule or not. Empirical rule requires your z-score to be like a whole number. It needs to be like a round number. I should say an integer. Okay. Like 1, 2, -1, -2. But let's see if we got 6.2. Let's get that z-score. If it's between, though, I'm going to have to calculate 2 z-scores. Okay, one for this guy and one for that guy, and then I will subtract their table values. So let's do 6.2 here minus the mean is 6.2. Okay, so we got a z-score of 0. Which means that is 50% in our table, and I didn't even need to look that up. Right here sorry, that's Z1, this is Z2, for 4.7 minus 6.2. Let's see if that is 1.5. 4.7 minus 6.2. It's negative 1.5 divided by 1.5. is negative 1. Okay, so this means that we are from the mean here, and we're going back 1. So what percentage is in between there? And the answer is 34%. 30% of the data is in between these two regions. How about between 7.7 and 9.2? Okay, well, let's calculate those. 7.7 minus 6.2 over 1.5. That will be our first z-score. Okay, that's going to be positive 1. Z2 is going to be 9.2 minus 6.2. 3 divided by 1.5 is 2. So our z-score is 2. So we're looking for the data that falls in between here and here. Okay, and what is that? Isn't that 13.5? Okay, 13.5. All right. I don't think it's 12.5, is it? I don't think so. All right, 4.7. 4.7, we were negative 1, but if we want less than this, okay, less than, we want this area. We already calculated that it's negative 1. So this means that I've got 13.5, and then this guy's 2.5. So that is a total of 16% if you're going to be less than negative 1 standard deviation. Okay, if you're greater than 9.2, 9.2 is here. We already calculated that as 2 standard deviations. So if you are over here, all that area is 2.5%. Okay, and this is just the empirical rule right there. Okay, that's all these guys are. Now, for this one, scores on the Algebra 2 Common Final Exam are normally distributed with a mean of 74 and a standard deviation of 10. Your school tested 225 students. Okay, so this last piece, if I have the number of students, if I know the percentage, I can easily multiply this to that value. And if I do, that will actually give me the number of students, not just the percentage of students. Okay? So let's get this score first. Looks like these are going to be kind of clean, or at least this first one is, the z-score here. is 94. So 94 minus 74 divided by 10 is going to be 2. So how many scored above? Now we know that that is 2.5% that scored above 2 standard deviations, right? That's this group right here, so 2.5. So now let's take 0.025 times 225 students. That's 5.6 students. So how many students scored above? Well, it looks like we have 5.6. So 5.6 is how many? Is it 5 or is it 6? That's a good question. So if it's 5.6 that fill in this gap here, what I would do is just round. Do we round down or round up? So you've got 5.6 students. Let's think here if it's 5.6. Let's think of the other direction here. I need to go 0.975 times 225. Okay. Now that's 219 students. So what you should say is that I would, let's round up. So there's 6 students. We'll round up. How many score below 74? Okay, or 64. So 64, man, these are kind of nice because the standard deviation is right there. So we're looking at that. That whole area here is 16%. So let's go ahead and figure out what 0.16 times 225 is. So 36 students scored in that ballpark. How many students score within 1 standard deviation of the mean? Well, that is going to be 68%. Okay, because that is 1 here, 1 here. We know that these two regions together is 68. So 0.68 times 225. It's 153 students performed within 1 standard deviation. How many performed within 2 and 3? Well, we know with 2 standard deviations, that is 95, right? Right. Let's see. 13.5 plus 13.5 is 27. 68 plus 27 is going to be 95. So 0.95. Okay, that's 2 standard deviations times 225. Okay, so we got 214 students for 2 of them. Okay, and then for 3 standard deviations, we're going to go, that would be 0.99. 3 standard deviations, 0.4. So we're going to take 100% and minus 0.4 minus 0.4. So 99.2. So 0.992 times 225 is 223. Okay. 3 standard deviations. Okay. Now, are they going to get harder than that? Well, yeah, that's what these guys are for. Okay. All right. This will be another video.